Hello, I'm Axel. I'm heading the group of evaporation and boiling at the Technical University in Darmstadt. And today we joined the first day of the 71st parabolic flight campaign with our experiment, which is dedicated to boiling processes. You can easily imagine that you just have a heated surface and you get a bubble from this heated surface, like on boiling an egg or boiling pasta. And we are interested in the basic physical phenomena to understand this process. And that's the reason why we go to space, because if you do this on ground, the process is very, very fast and it's not possible to observe it in such detailed manner like we do in parabolic flight, because in here the process is slowed down. And what we want to do next to this aim is to also find some ways to calculate and to build heat transfer devices for space, for example for satellites or on the ISS, or maybe later also for housing or houses on the moon or on the Mars and things like that.
Hi, I'm Matthias. I am working in a group of Axel and Peter Stefan at the Technical University of Darmstadt, and I'm part of this parabolic flight campaign.
Hi, my name is Christian Wolf and I work also at the Technische Universität Darmstadt as a scientist. Normally I investigate the wetting of soluble surfaces, so I look at small droplets and them interacting with surfaces, which is quite the opposite of what I study now. So we could say bubbles are negative droplets.
Alright, my name is Sebastian. I'm from Technical University in Darmstadt, and I'm part of the team doing my master thesis here. And my basic task was to optimize the experiment from the last time. So when the wreck flew last time, there were some issues, some difficulties, and I had to solve them. And yeah, part of this was the bellow. So I had to optimize the pressure system, or to adapt the pressure system to put the pressure or to adapt the pressure in the FC72 circuit. Some other things were optimizing security stuff and to adapt some things that Novespace wanted us to do, just to make the rack as secure as possible. And yeah, I'm very grateful for the opportunity, of course, because that's something not everyone can do, especially in this thesis. And right now that's more or less the end of my thesis, so I already worked 4 months for it. And now I got to write my thesis, that's the last part. And yeah, I'm really happy to be here, and I look forward to the next flight days. And I'm sure it will be fun.
Thank you very much, Sebastian.
Perfect.
Enjoy your flight.
Thank you.
So why this experiment is important?
This experiment is important because boiling processes itself are not really well understood so far, and doing this experiment in weightlessness we can slow down the whole process and understand it much better than we could do it on Earth. And we can use this on the one hand for enhancing heat transfer on Earth, but on the other hand we can also use these results to build heat transfer applications for weightlessness, like in satellites, like on the ISS, or even in future for other planets.
Merci.
Yeah, the bubbles are going to be produced in here, and we also have the black and white camera over there and the light source here, and so we can view the bubble growth.
Hello, I'm Axel. We're now in the 16th parabola and we have just prepared a new parameter set. Christian is the operator of today. Sebastian is dealing with the red camera and I write the protocol and look with the black and white data. And if we now reach soon zero gravity, we will see on the screen how the bubbles grows. So now Christian is starting the measurement.
Measurement started.
Laser light should go on now. And now we got pictures on the camera with our boiling bubbles.
Thank you very much.
You're welcome.
That's perfect.